Good day. Today, our group FAISSry is presenting.
A retrieval-augmented dental knowledge for common oral health queries.
My name is Yong-Yi. We are standing at an inflection point. For the last few years, we talk about generative AI, writing poems, generating pictures, but the promise of AI, the multi-billion-dollar shift, is when it starts solving fundamental human problems like health. My incredible team, Richie, ELMER, SHARON, MICOLE, ANGELINE, and myself, Yong-Yi, have been looking at the Sustainable Development Goal 3, good health, and well-being. Realize there's a massive disconnect how people access basic critical health information. Let me show you. We call it the tooth fairy. So the problem, have you ever Googled a toothache? The results is terrifying. You type in why do my gums bleed, and within 3 clicks, the internet tells you your jaw is going to fall off. The information is scattered, is sometimes overly technical, and half of it is trying to sell something. So people try to turn to LLMs like ChatGPT. So what's the problem? With standalone LLMs, they are incredibly confident, but sometimes they are wrong. When it comes to healthcare, hallucination isn't a glitch, it's a liability. You cannot have an AI giving confident, unsupported medical advice because it's an impossible problem until today. So look at this. We didn't just build a chatbot, we built a retrieval-augmented dental knowledge assistant. We took a powerful language model and anchored it into reality. So the first step is we ask the patient a question. Then the second step is the system checks if there's a query and actually in the dental domain. The third step is we execute a lightning-fast hybrid retrieval, the FAISS plus BM25 model. And the fourth step is when the model generates an answer. But here's our secret. It's only allowed to generate an answer based on retrieved verified context. It's always grounded and it will be safe. In the next slide on dataset overview. So how do you make an AI a dental expert? You feed a textbook. We ingest it with Math MCQA dental subset. Not just a Wikipedia, it's over 10,000 rigorous exam-based medical questions. So within textbooks, it's dry, but patients don't like textbooks, so we augment them with vast library dental reference PDFs, orthodontic gum disease, implants, oral cancer. We feed it the clinical data and we feed it with real-world patient context. So below we see a pre-processing flow, and the raw data is messy. You can't just dump PDF into a neural net and expect a miracle. You have to build a pipeline. So we built a data engine with minor U, strip out the headers, footers, and noise, and we use LangChain to chop the text into perfect semantic chunks. It's between almost 300 to 500 words, small enough to be precise, and large enough to hold context. Then we index it. We create a dash vector using an embedding model and load them into FAISS, semantic meaning, and we create a sparse keyword index using BM25 model. So we processed it, we chunked it, we vectorized it. That's fantastic. So in the next slide, we talk about the solution architecture. So that right here is the architecture, is our magic. So look at the flow. User types a question, why do my gums bleed when it's brushing? So the first guardrail layer is this dental? Yes. Next, hybrid retrieval. FAISS, look for the meaning behind the question. BM25 looks for the exact words. Then we use a reciprocal rank fusion, combine them. But we don't just stop there, we run it through cross-encoder re-ranker. This will act as a ruthless editor, picking only absolute best supporting context. So finally, then the context, we pass it to Gamma4. Gamma4 generates the answer, grounded, safe, accurate answer. So next slide is on guardrail and domain control. I want to talk about the guardrails because that is what makes the enterprise-grade medical tool. What happens is if you ask FAISSry about fixing a car engine, it will reject it. What happens if the re-ranker score is too low, meaning we don't have enough confidence in the medical literature? It rejects it. So then we build an AI boundary. Literally gives you a safe deflection output, no sufficient similar context found. And AI actually admits when it doesn't know the answer. Incredible, right? So everyone loves benchmark. So does it actually look good? We ran the regards metrics, context precision, recall, and faithfulness. We put our gamma 4 rec pipeline up against a standalone gamma 4 and against a standard GPT-40 mini. Look at these numbers. The answer here is the relevancy for gamma 4 hits at 0.9 and for GPT-40 mini is at 0.80. And semantic similarity we hit at 0.89 and the 40 mini GPT we hit at 0.67. And the most important metric on this screen is the factual correctness. The standalone underground model struggles, but our RAG pipeline achieved a factual correctness of about 0.82. We absolutely crushed the baseline. The more relevant context you retrieve, the less you hallucinate. It's a direct correlation. Faithfulness sits an amazing 0.91. Cool, right? Okay, so now let's put aside vector math and cross encoders. Let's watch the demo. Watch this. Look at the speed, look at the precision. It's not handling text only, it's sample learning medical model. That is very cool. So we're testing out a big question, something irrelevant. And also delete it. After that. UI is quite responsive. Okay, that's it for with demo. So what did we achieve? We took a massive fragmented domain, human knowledge, dental health, and we made it accessible, reliable, and fundamentally safe. We used a hybrid retrieval to find the needle in the haystack, and we used strict guardrails to limit hallucination. But wait, we're just getting started. The future of FAISSry is even bigger. We're going to integrate thousands of more PDF sources. We're going to fine-tune re-ranker thresholds, and we're going to explore rerunning them entirely on local models and local embeddings. So this will give us total privacy and zero latency. We're going to democratize healthcare knowledge, and we'll do it safely. That's all from our group. Thank you.
I'ma get closer to you, yeah.